Okay, great.
And your life.
Good morning. I'm Chandler Archuleta. I'm a cyber system engineer at Northrop Grumman, and today we're going to talk a little bit about machine learning, cell phone and firmware hacking, and even a little few cracking techniques in firmware. So let's get started. First, we'll talk about machine learning. So machine learning, right, the big thing you got to know here is there's a big difference between humans and machines as far as patience. Humans are really bad at doing the same thing over and over again. They get bored and it costs too much. Computers, on the other hand, do things over and over again, and they don't cost much to be able to try the same thing over and over. So that's the core concept of why we use machine learning in hacking and defense, of course. So machine learning automates the scam attacks. So what you do is you go in and you set up your attack chain. You do a little bit of offensive prep for the battlefield. You go ahead and set up your machine learning, and you go against the mail server, the global address list, the network, whatever you're learning about. Then, as your machine fails, it tries new techniques. So, in traditional machine learning, you have a huge digest of information that your machine has to use to be able to be trained. In this case, it's learning on the job. This is on-the-job training for your machine learning for in this particular hack. So you can use it for penetration tests. You can use it to test the social media hygiene of your employees. You can use it to see if your team is susceptible to spear phishing. It dramatically improves the reliability and reduces costs. The way that it improves reliability is by failing quickly. So humans, to go in and fail, you would have to go and look at the data, and then you have to change your attack. But for a computer to do it, you set it up in the string that it's supposed to change each time and try a different type. So it instantly goes out, hits all of your targets, and then changes based on what happens. If it's successful, it continues that successful hack. If it fails, it tries a new hack. And it reduces cost because I get paid by the hour just like you do, but your machine does not get paid by the hour. The machine just keeps going until you tell it to stop. So here's a little bit about prepping the battlefield. I'm sure many of you have used recon.ng or Google Dork. You go in and take a look at what at the target. Right, you go in, you use Kali Linux or another tool to be able to figure out what exactly is the vulnerability you're going to try to find on the target network. Then you can buy yourself some legitimacy by getting yourself a domain, right? Like this domain here, that expertantivirus.com, right? If you get an email from that, especially if you're someone who's susceptible rather than someone who thinks in offense and defense like you and I, then hey, this is expertantivirus.com. This is great. Oh yeah, I should really respond to this email. And if it doesn't work, guess what? Your machine can do it again with a different domain for another $3.99. The benefits to using machine learning are that you get an automated attack cycle. It can go over and over again, and it can adapt based on how you've pre-programmed your machine to learn over time. The reuse is nearly free because your computer just goes into its next routine. It doesn't have to be able to go back and get paid, have a rest like we do. It just keeps going. It can overcome spam filters and network defense tools. The way it does this is through trial and error, not by being smart, but by trying over and over again. Computers are relentless. That is how machine learning really works, is the relentlessness of the machine to try over and over again, fail fast, and then adapt based on the failure. Next, let's talk a little bit about cell phone hacking. So I'm not talking about going into someone's cell phone and being able to figure out how to get their credit card or be able to go into their cell phone to mess around with the code. What I'm talking about in this particular hack is how you would be able to use a vulnerability to be able to track a cell phone. So we'll be talking about how you go in, find vulnerability in in a protocol, and be able to use that vulnerability to your advantage to be able to track a cell phone. So in this case, what you do is you'd fake a SIM card and use a fake base station to overcome the SQN, the sequence number, and be able to exploit an inherent vulnerability in the authentication and key agreement protocol. So some of the benefits here are that you can use it on 3G and 4G, and it works within about 2 kilometers. Of course, if the target's moving, you're going to have to move too if you want to keep that to kilometer distance. So what's the methodology? How does it work? So you use the SS7 services HLR lookup to be able to find the IMSI from the phone number. Every phone has to have an IMSI. If you want to be able to work with the towers across the world, in your cell phone, be able to find the tower, work with the tower, get your phone call to where it's going, you have to have an IMSI. So every single phone has one, and you can't change it. In your card reader, you pre-program the SIM card with the target's IMSI, and this costs about $1,400. So you do have to have the software and the tool to be able to basically blank out the key and put the target's IMSI on, so you look like you're their phone, right? Then you go in and you start to exploit the vulnerabilities. The first vulnerability is that you have symmetric keys used in AKA. So what that means is the key is the same. So as you go in and you ask for a request, you're able to know that your key would be the same as their key, the target's key, and your key, attack key, would be the same. You go in and use that against AKA. And the great thing is there are unlimited attempts. So you can go back and forth between looking at the different responses from AKA. And then once that incorrect SQN number comes back, you know it's a failure. But then when the correct one comes back, you know it's the right one. And as soon as you have that code, you're able to use that code to be able to track the cell phone. So in the last part of this is talking about firmware cracking. So really, in the last 5 years, the hottest things are firmware, memory, and clock. The reason for those are our defenses are getting better all the time, which is great, right? That's why I'm in the business. That's why you're in the business, is to be able to make things more safe and secure and better for everyone. But some of the things that are hardest to protect are some of the things that people think about the least, and that's that firmware, that clock, and that memory, because we don't generally work with it, right? Where we're using our man-machine interface or our man-machine teaming, and we're really working with what we can see. We're working with the top end of the stack. We are not working with the bottom end of the stack on a daily basis. Anyway, this particular one is about firmware. This was found with a bug bounty. And so I highly recommend going out and looking for vulnerabilities and then getting paid for it. The firmware vendors will pay you to go out and find vulnerabilities like this. And this particular one, it was in the thousands of dollars. I think $10,000-ish range for the team that found it. So you go in this particular hack and you get physical access. You get physical access to a computer. And then you use the firmware to be able to get into the hypervisor to get into the secure kernel of Windows 10. When most people make their computers, they don't put in firmware protections. They do put in antivirus. They do put in different things to be able to protect your computer, but firmware is usually the last thing anyone thinks about. So what we do is we modify the secure kernel by bypassing the hypervisor that's in between the W10, Windows 10 security kernel and the firmware that we're getting in through. When's the last time you updated your firmware? I bet a lot of you are going to say never. So make sure you go in and update the firmware in your computer. All right, so let's talk a little bit about how it works. So the methodology for this one is a direct memory attack. You use the PCIe config because the access is open, right? So your PCIe card connects you out to be able to use TCP/IP to be able to get back and forth between the network, either the network or the internet, in most cases both, right? So you get into through the PCIe, and then you use the lasso lump unprotect credential command to be able to unprotect. Then you go in and you look at the hash. So you're gonna have to use a brute force to be able to figure out the hash, right? And this is how we overcome most encryption, right? Is we go in and we compare hashes to be able to figure out when we find the right one. And as computers get faster, memory gets better, and as processors go faster, we're able to look at the hashes much faster than when they were originally set up. You know, Arapanet was originally set up before the internet to be completely open. Then we started to figure out we needed to protect TCP/IP, but things move so quickly and the technology is going so fast that as we learn our protections, of course, the hacks are going almost as fast. So what you're going to do, you see here on the right, the bottom of the stack is how you get in through that PCIe. You're going to be able to go in and get through the hypervisor. Then you get the secure kernel. Once you get to the secure kernel, you're able to update anything in that computer. That gives you keys to the kingdom. Once you've got that, you can get anything that's on there, including encrypted keys, including hashes from passwords, including private keys, right? There's so much you'd be able to get through this technique. That's why it's so important to go in and update your firmware, or if you're in charge of a network or a corporation, to make sure everyone is updating their firmware. So that's a little bit about machine learning, a little bit about hacking cell phones, a little bit about cracking in firmware, and that's what I wanted to present you today. So thank you so much for your time, and I'll take questions if you have some.
You can throw questions in the YouTube chat. In the meantime, would you mind talking about yourself, Chandler?
Oh, sure. So I'm Chandler Archuleta. I started in the Air Force. So in the Air Force, we used public exchanges. So computers started in very large rooms with modems and with technology that got uh, networks back and forth. This is long after ARPANET and TCP/IP, but before we really got into computer security. So the first things we were trying to protect were modems, and at the time there was dial-back modems. So I would actually call into a public branch exchange, and then it would call me back on my cell phone, on my number, and my telephone number was my identification. So you can imagine how bad and how poor security was back then. So I went through the Air Force and then started working for the Pentagon, protecting computers there. Then I started to protect computers for the Navy. Then started to learn about Northrop Grumman and how we went out and were able to have these huge events with planes and ships and tanks and backpacks all talking to each other, and learning how to secure those networks. From there, I went in and became a manager, and now I really work on both the latest offense and the latest defense, because the best defenders are the ones who understand how the offense works. So, of course, I don't attack anything. It's all virtual, but I learn all of the latest techniques to be able to protect the systems. And it is really, really fun job.
And we got a question asking if the viewer had issues or questions about the terminology, where could they learn more about it?
Oh, sure. So I would say, if you really want to learn the latest attack trees, MITRE is the company that puts out really good information. So the CCVs, you've probably seen these before. That's the vulnerability reports. If you go to MITRE's website and you look up the latest attack trees, you can go through and learn the technologies of what the different attack trees are. Like firmware, for instance, is all the way down in the OSI stack, but there are ones that are against the top of the OSI stack as well, what we're in the application layer that we're more attuned to. So that's probably the best place to go in. And I know that they are starting to build dojos too, so you can go in and start to be able to do attacks and protections in the same dojo. So that's a really good place to start, is MITRE, for the really best. And MITRE is a company that is a nonprofit, so they work for the government. So they're really good about sharing the information, because they want everyone to be able to benefit from the information.
So where would you go if you want to start in cybersecurity?
So the first thing I would do is get an internship. So by getting an internship, that's the best way to get your foot in the door, to be able to get a clearance, and also to get the latest tools for yourself. So you can get an internship with the government, you can get an internship with Northrop Grumman, you can get an internship with any defense contractor. And by getting one of those, you're going to be able to get your foot into cybersecurity right away. And as you build up that, you're able to build up not only your resume, but also your knowledge. And the longer you're in, the more cool assignments you get to do. So that's one of the best ways to get started. If you've already graduated, then an internship may not be what you want to do. You may want to go in and get a certification. That's the next thing after college I would do, is go and get a certification. There's the Certified Ethical Hacker is probably the one that has the most offensive information in it, but there are many good. If you go to 8570, that's a DoD manual that tells you all the certifications that the government recognizes, and it gives you a lot of good options for certifications that'll help you really build your resume and get that great job.
And do you need to have a lot of experience in cybersecurity to get these internships?
To get internships? Oh no. For internships, it really, we're looking at the things like this. Like if you're participating in hackathons, if you built your own virtual private networks, if you've learned how to use C++ or Java or Kali Linux, all of those things really are what stand out for me. When I'm going to look for someone for an internship, I'm really looking to see, have you tried any of this thing? And hackathons are a perfect place to go in and try different attacks and to learn about the defense and the language of cybersecurity. So no, you don't have to have a ton of experience. Yeah, but it helps to go and tinker around and be able to speak about tinkering and tools in your resume.
What's a good beginner project or something that someone who's interested might want to check out?
So I would start by going and checking out the videos from both Black Hat and from DEF CON. If you go and look, that is really the latest on what's going on. They're really good to be able to figure out how would I do a project of my own, how would I build something up and try some of the latest techniques, because they'll show you live what they're doing. So you can go in and build up build a VLAN, right? If you have a VLAN and you're making virtual machines, that is the fastest and easiest way to be able to try things. And Kali Linux is probably the easiest user interface of all the hacking tools. I think Kali Linux is the best because it has a really full suite of tools, and most of them have really good help files to be able to tell you how to use them. The CH bootcamp is also really good because you will live hack on the VLAN. So your instructor will show you in the bootcamp how to live hack. So it's much different doing it to learning it, because there's a lot of trial and error, a lot of failure in trying, especially with wireless hacking. So it's good to have someone, a Sherpa, help you. Someone who works in forensics is really good.
So while I wait some more questions, do you have anything to say about Northrop Grumman itself?
Oh, yeah. So Northrop Grumman is a enormous corporation. We're global, so we have offices all across the world, and of course in all 50 states. We do some of the latest things. Some of the fun things that you'll read about and recently in the news is we're doing the solid rocket motor for the vehicle that's going to go get the data from the lunar, or not from the lunar, excuse me, from the Mars expedition that's going on right now. So there's really exciting things like that going on, like in space, but we also do terrestrial things. We do ships, we do underseas. So being in a really large corporation like that, you get to learn a lot. Some of the funnest things I've done at Northrop Grumman are electronic warfare, where instead of blowing things up, you're learning how to do that chess game of offense and defense through really through algebra. You're going in and you're creating algorithms, and you're figuring out how to be able to use the sinusoids and all the different parts of a signal to be able to defend and to attack different parts of the spectrum, which is pretty exciting and something that I highly recommend. A little bit more about Northrop Grumman now as we finish his. We're a highly ethical company, which I really like. One of the reasons I like Northrop Grumman is we do the right thing, and that's part of our values. So all the way from the top to the bottom, it is a company that we go and pioneer and we take risks. And the reason it's safe to do that and to do things that are really risky and uncomfortable is that the corporation's always got your back. they're always going to do the right thing. They're always going to, it's, I've worked for a lot of corporations, and this is the only one where I have reached to many different people in the organization, and they always take my call. They'll always set up a one-on-one. They'll always answer my questions. They'll always be honest about why we can't do some things and why we're able to do other things, the reasons behind things. It's really one of the most transparent cultures I've ever seen in my experience. So that's one of the really great things about Northrop Grumman that I don't think gets talked about very much, because it's part of the culture, but it's not really something that's marketable. But it's really important to me as someone who works there.
This is like one of my own questions, but how has Northrop Grumman reacted to stay at home and whatnot?
Oh yeah. So at first it was really scary because so few people work from home. We didn't have the pipes, right? We just did not have enough bandwidth. So they reacted immediately, set up a council to be able to work on the problem, opened up VPNs so that we were all able to work from home. So, we went from maybe 20% working home to 90% working from home. I'm making these numbers up, but that's similar to what it was. And then the culture changed because a lot of people felt like they needed to be in the office to be able to work with each other because they'd always done it that way. So by the majority of the company all of a sudden working from home, we learned totally new ways to collaborate. One of the favorite ways in Northrop Grumman to collaborate, for instance, is a whiteboard. We'll all sit around a whiteboard and then try different things. We'll build an environment and a scenario and put everything in there and work out the math on the whiteboard, and then argue back and forth for the best solution. Well, that went away. So we all had to start to learn how to use Skype and how to use Zoom and other ways to be able to communicate with each other than using the traditional whiteboard. And one thing that it did, it really gave people an equal footing at the table. It used to be, kind of the most powerful person in the room really was the person who was getting the most attention and was speaking most of the time. But in the new virtual environment, people have really learned to collaborate better and share better. So Northrop Grumman has really adapted quickly to this new environment where most of us are working from home. And they put in protections, of course. Where I go into work, there's things that spray in the air to be able to protect us. And then, we don't have to touch the doors. The doors open automatically. We're even trying to do things that take temperatures so that you can make sure you know your temperature before you go into the building. I mean, just amazing adaptation. I think that was the biggest thing that really changed with this new environment of us all working from home, is everyone started to adapt faster and be able to react to change and be able to learn a whole new way to work. It looks like as the culture continues too, we're going to be able to have more people working from home. So we're not going to go back 100% to how we were. That original council that was set up to be able to make it so that people could work from home is now working at the gig economy to figure out how do we bring work to the people and people to the work in ways that we can use VLANs and virtual workforce in ways we never did before. Like, I don't think as many people had used Puppet and GitHub and that sort of thing to be able to share code, for instance, even though it was something that was definitely used. And now it's used by everyone. So everyone really understands how to be able to share things, not using their hard drive, but using the tools that have been adopted by more of the community that works globally. So it's an exciting time. It's an exciting time to be at Northrop Grumman, that's for sure. A lot of change in the air, and a lot of fun pieces going with the digital transformation. People really getting used to, hey, this is how the future is going to be. So let's be part of it.
And with a question saying that if you have a machine learning background, but you're interested in cybersecurity, how would you start?
I'm sorry, what background?
A machine learning background?
Oh, machine learning. Oh, yeah. So if you wanted to get into cybersecurity from machine learning, one of the best ways to be able to do that is to look at jobs that will say machine learning in them, but are in the cyber career field. So you would be called a cyber system engineer or a cyber engineer. That's the words to look for. But look in the description of the job, and if you word search in this description of the job for machine learning, you'll see jobs that are include machine learning for people who are in cyber. The other one that people don't really think about a lot is the analytical part of machine learning. So when you're working on anything in sensors, anything in medical equipment, anything that's having to take large amounts of data and be able to, as someone who uses machine learning, taking huge amounts of data and turning that into information, make sure you talk about that in your resume as you apply to cyber positions, because a lot of times cyber professionals don't realize, because they just haven't used machine learning as much as you have, how that really takes those large sets of data and turns it into information. If you put that at the top of your resume, then they'll definitely see that and be able to make the connection to, oh, okay, well, I need to take huge amounts of sensor data and turn it into information, or I have to be able to look at a bunch of medical data and be able to figure out what's anomalous. Then they'll understand that is machine learning that you have done is absolutely applicable to cyber. So that's how I would approach it if it was me. We also have a lot of data scientists that come to us, and mathematicians and physicists. This is the same type of language. You want to put that right up at the top of your resume so that people can make the connection, so they understand, oh, okay, because you understand physics, then you would understand how signals propagate through water, for instance. And that's really important for us to be able to understand how ships be able to navigate, or how we're able to look at things in space. All sorts of different applications come up, but it's really important that you make that connection for the person who's reading your resume, because a lot of times they're a screener. They're not free thinking like you are. So be able to make that connection for them. We just did a project. I had 2 years ago, I had a team of people working with me. We were doing natural language processing, and machine learning was a huge part of that. And boy, was that a fun exercise to figure out how you take these huge amounts of cyber data, right? You're going out and you're looking at all the different cyber data that's coming in from all sorts of different sources, and using a machine to read those instead of a human reading those, because it makes it so much faster. And then turning that into a visualization, a 3D visualization that a analyst can look at. So instead of having to read 300 boring reports, now they're manipulating a 3D mesh of what all that data looks like to be able to figure out and make connections and be able to find relevant cyber data. So machine learning is absolutely applicable to cyber. Absolutely. I mean, we're definitely using it. And I certainly look for that. I look for data scientists and I look for machine learning people when I'm looking for cyber engineers.
We had a question asking, what classes/electives do you think are most important for internships or jobs at Northrop Grumman?
So the really hot things are C++, Java, Linux, any projects. Like if you actually do work on something, so you're building a quadcopter, or you're working in a laboratory, or you're have a finished product, like there's a white paper or a presentation at the end of your class that you can then use. Those are the classes I think that I would concentrate on. If there's a digital forensics class, that's also really useful, because you learn the deep dive in how computers work and how you find problems. Let's see what else. Electrical engineering is good. So if you have classes that use a lot of MATLAB, that's also really useful, because a lot of our data goes between C++ and MATLAB. So if you understand both C++ and MATLAB, then you're able to take the algorithms, but then turn those into actual software programs that make things work. So that's a really fun part, but also something that not everyone thinks about, but is really useful if you have those combination of classes.
And what do you look for specifically if you're hiring on a resume?
Oh, sure. So the first thing I look at is, does this person have a clearance? So that's where the internships come in, right? That help you have that. And then I look at the tools. What tools have they used? Have they used Kali? Have they done C++? Do they use Java? Do they use any of the cyber tools that I use? MATLAB. Do they go out and learn on their own and set up VLANs? Do they understand how containerization works? Do they understand how to be able to use GitHub and Puppet and Docker and all of those types of tools really do help. If I see that at the top of a resume, it really helps me. Then I look to see, has the person got a way to clearly communicate? Does the resume make sense? Like, as I read through it, is it telling me a story about how that person is a good fit for my organization? So I first start with the clearance, then I go to the tools, then I go through their experiences, and those experiences come from anything, whether it's volunteering, whether it's an internship, whether it's a work experience, whether it's their own experimentation, whether it's a class. All of those count the same for me. So make sure you take credit for the things you're doing, like doing a hackathon. That absolutely counts. Make sure you talk about all the tools used in the hackathon. Make sure all the concepts you learned in the hackathon. If you won, make sure you say, hey, I won a prize because I actually was the best at this particular attack or this particular piece of information gathering in my hackathon. All of those things count. So make sure those are in your resume.
How important is a populated GitHub portfolio when you're looking at a candidate?
So it's important that you know GitHub, but your portfolio does not have to be populated. So I think if you do have that, it will set you up for success in comparison to your peers. Like if you're in an interview and you talked about that, then it's really important. But to be able to get to the interview, it's not as important. So it's something that will definitely help you, and make sure you mention that in your interview. But it is that you have knowledge of, or that you know how to use GitHub, that will get you to the interview, if that makes sense.
And so what I have a question saying, so what did you mean by in front of your resume? Do you mean as a headline on your resume?
Oh, yes. Yeah. So when I do resume reviews and try to work with people, so in what I mean is the top. As you're reading the resume, the top of the resume is what is read the most, and the bottom is what's read the least. So make sure the tools are near the top so people can see them. And if you're trying to make a connection between what you know and cybersecurity, make sure that is in either your desired position or your description of yourself or whatever you have in the top material. Make sure you make that connection for them early in the resume as you're reading from top to bottom. That way they'll make the connection and not say, oh, this is someone who's has a different discipline, so I'll put that in the maybes. Instead they'll look and say, oh, I make that connection, okay, let me put this in the definitely want to interviews. Hopefully that makes sense. Did that answer the question?
They can answer that, but I think that made sense.
Okay.
But also, a question: if someone doesn't have a clearance, do you cover the cost of getting clearance? How long does the
We
clearance
absolutely
process
do.
take?
Yes, Northrop Grumman will cover that. So between Northrop Grumman and the customer community, and depending what you're working on, it's absolutely covered. There was no expense to you whatsoever to be able to get your clearance, and it's extremely valuable. It is extremely valuable. Not only does it show that the community and the government trust you, it also gives you access to be able to see behind the scenes on what's going on, to really give you an idea of what the threat landscape looks like. And it makes you the best possible professional, because having access to that knowledge really helps you to be able to have the latest techniques and be able to understand the missions.
How long does it usually take to get clearance?
It depends. Sorry. I know that's an annoying answer, but it's the truth. It can go as fast as 6 months, and it can take, over a year. So it really depends. Usually people who get into an internship, or by the time they do their second internship, they almost always have their clearance. So they'll get their clearance in between their first and second internship. That's usually how it works. But it can depend.
Are there certain factors that make getting clearance longer?
Yes, yeah, it depends on, are they able to get a hold of the people that you have put in as your references? Did you quickly answer questions and get your information into the system? Have you lived a lot of different places? All that factors in, right? Because they have to go and look at your background. So the more complicated your background is, the longer it takes to go and do that investigation. Whereas the more simple your background is, the easier it is to be able to gather that information. It's just like any other information gathering.
Is it okay if candidates don't necessarily have every single skill desired?
Absolutely. Yes. In fact, I don't expect anyone who is beginning their career with me to know everything. I expect them to have something that's a strength, right? If you come to me and say, I'm really interested in learning MATLAB because I want to be able to go and use Simulink to be able to create, wafer boards, for instance. That's really your way into that. But my core skill is C++, plus plus, so I'm going to have to grow into MATLAB. That is no problem at all, right? If as long as I know you're really strong in something, then I'm looking to build you up in the other areas so that you have a really broad knowledge. Every person who comes into me usually is a specialist in something, and we try to work them towards system engineering so that they can know a bunch of different things, just because it makes it a more robust, interesting career. If you can try a little bit of everything, it just makes it so much more interesting as you go through your career. It makes you so much happier of an employee, and really um, makes you love the work you're doing. So, absolutely, you do not need to know everything to be able to get an internship or a first position. That's not expected.
So, what do your interns usually do?
Um, well, I usually do a project with my interns. So I talked a little bit about the machine learning where we're doing natural language processing, but we also did a group that did AI, where they went out and they did some neural nets to be able to have computers think in a different way. Um, I've had interns go and work on projects where we're doing flight tests. So they would take the data from the flight tests and be able to parse that data to be able to figure out, was it successful or not. We usually give them experience in the laboratory so they can go in and set up test sets, set up environments, and be able to run a test all the way through, so they understand, the full life cycle of a laboratory, and how we take something from concept and turn it into a prototype and then turn it in eventually into a product. Um, it's usually hands-on. I try to make something that they can do over the period of time in their internship. So it's like a project that only lasts a couple of months, but they can actually have a milestone, something at the end that they can turn in and brief, and something that is part of their portfolio forever.
Are these projects used after the internship?
I'm sorry, one more time, Victor.
Are these projects usually used after the internship?
Yes. Yeah, absolutely. Yeah. So I would say 80%. So 100% eventually, but 80% pretty quickly. So most of those projects they'll either go into a proposal where we're talking about, we learned this latest technique and we're going to be able to use it. So we'll propose to the government or a commercial customer, hey, we can use this. So um, it'll go into the proposal and be used that way. If it's a prototype, then we'll go and use that in a event. So we go out and do huge exercises where we'll go and test out a prototype and see if it works in a real wartime environment. Or it turns into something that becomes IP or intellectual property. So we use that intellectual property to get patents or be able to update products that we already have to give them another mode, or be able to get them to the next level of technical readiness level, TRL level, so that they're more mature. So they get implemented. It isn't that they turn into a ship or a satellite or a submarine. It is that they adapt, change, or make something better, or give us something that we can propose as a new capability or a problem solving technique for our customers. That's what they usually turn into.
What does a typical workday look like for you in terms of number of teams you're a part of and projects you're working
So for me, I have two different, which is common. So you begin your career usually working on one project, And as your career progresses, you'll take on more than one project. So for me, I have a team of modeling, simulation, and analysis engineers. And so I work with that team to be able to get them what they need. Do they need a computer? Do they need software? Do they need a mentor? Do they need a new project? All that type of thing to make sure they have what they need to do their job as a manager. That's my job. And then the other half of my time I spend on a project. So right now I'm working on space. So I'm figuring out how do we make the best satellites that can help us explore this amazing world that we have. So on half of the day, I meet with my team, see what they need. I do one-on-ones with them. I approve things like their timesheets and their software requests, and advocate for them on projects to talk about how their skills could be applied to new and interesting projects. And then the other half of the time, usually spreadsheets, some computer work, some meetings, a lot of strategy sessions. I tend to favor brainstorming, strategy sessions, collaboration summits, things where I can bring a bunch of brains together and come up with the best possible answer. So that's how I spend a large part of my day, is getting other people to come together, think with me, and then come up with the best possible solution. And then we run with that. We either turn it into code with software engineers, we turn it into designs with the hardware engineers to have things that are manufactured. If it's integration and test, we turn it into ways that we connect the systems together, or ways that we test the system to make sure that it's going to work. So that's how I spend the other half of my day. I definitely am always using PowerPoint, Microsoft Excel, Skype, whiteboards. These are the tools that I'm usually in. A lot of my engineers use all sorts of different things, but that's where I tend to take things, put them together, and then turn them into the final product for designs.
And to what degree are personal projects with new technologies encouraged at Northrop Grumman?
Sure. So we have a program where you can go and propose your ideas. So you can go in, propose your ideas, and if your ideas are something that has a business merit that will turn into something that really benefits either a customer or Northrop Grumman, then they get funded. So they get funded usually for a couple of weeks, because it usually takes a couple of weeks to be able to make a prototype or finish out a concept or finish out a research project, to be able to then see whether or not we can get that funded so that we can turn that concept or that prototype into a final model. So you can go in and put in those ideas. Let's see. I have an engineer who's done four. There's been about 3.5 months so far this year, and they've done four already. They've already gotten four IP disclosures, patents, or projects funded. So it's something that you can do pretty often. So, the top engineers would have something to be maybe 10 times a year that they do their own project and turn it into something. And then most people do it when they want, right? When they really feel inspiration hit, they've seen something or worked on something and realized, oh my gosh, this thing doesn't exist. I need to try this out to see if it'll work. Then they do that. One of the funnest things we're doing right now is anyone in the company who has an idea for how to test things in space, we're going to take their idea, put it on a balloon, and then we're going to send that balloon up into space to see if it works. So it's a really inexpensive way to be able to do a launch. So that's a fantastic way that we can try out people's ideas. So we're constantly looking to use people's ideas to be able to create something. So it's pretty normal part of our culture. I certainly have engineers who do that all the time, and I'm constantly giving them awards. Those kind of awards are fairly small, but they're things that are certainly financially good for those employees, and they do them over and over again, so they turn into larger awards at the end.
And before a pandemic, how was the social culture at Northrop Grumman?
So the social culture was very friendly. Like, you would go and talk to people, and you would meet in meetings, and you'd have 10 people in a conference room together. The culture was very collaborative, very transparent. So, like, I meet with my team every day. I'm having a one-on-one or a group meeting with people to talk about things in short term, right? Only 15 minutes. We don't want to spend hours in a meeting. That bores me to death. But spending 15 minutes, everybody working together. What do you need? How can we work together? Those type of things are a normal part of the culture. We're going more and more agile all the time. Scrum and Kanban, learning how to be able to collaborate quickly, fail quickly, and then recover and adapt quickly. So that's really where everyone is shifting their focus these days, is how can we take things that are analog and make them digital? How can we connect different technologies together? And how can we work together? So before the pandemic, that was very in person. These days, that's more on the phone or through Skype chat. So I guess it was more in person before that, but it was still already a very highly ethical, highly transparent culture. Like I've met with the CEO, for instance. I've met with the CTO, and I'm a nobody, right? I'm a nobody, but they took the time to sit with me and explain to me how things work and help me in my career so I can be the best engineer I can possibly be, and so I can have the biggest impact on our customers. I mean, that's a pretty big deal. Most companies are not like that. Northrop Grumman really has a great culture that way.
And is that still true post-pandemic?
Yeah, still true. Yeah, still true. So it's a little harder to get on people's schedules than it was before, because before in-person meetings were a little easier to schedule and everyone's schedule was not quite so dynamic. But what we've done as we've gone more agile is people's schedules do change a little bit more. So even I am still meeting with people and still having the good parts of that culture, but I have to be a little bit more patient in the post-pandemic world. Things tend to be more dynamic and move. So you'll still have that meeting, but you may have to have it rescheduled a couple of times. So it has changed a little bit in that way, but not in a negative way that you can't meet with those people or have that same exposure to the company and the culture.
So how long are your sprint cycles?
Usually 2 weeks. So I find that sprints are best if they're in 2 week cycles. That makes it long enough that people can actually have a product. Um, I personally am usually working on something that's in systems rather than software. I know software cycles can be a little bit shorter, but in my systems culture, to be able to get something that's a minimum viable product or a pilot, it usually takes a couple of weeks to finish a sprint and really get those things from the backlog into something that we can measure and make sure that it's what we need for the next sprint.
I think you might have answered this a little bit in your answer, but could you describe what a cycle looks like for one of your projects?
Sure. Yeah. So for us, we use Scrum. So we'll go and we'll meet for 15 minutes in the morning, and we'll talk about three things. Right. We'll talk about uh, what did you do yesterday? What are you going to do today? And what do you need? What are the challenges or the things that are holding you back? And so once we go through those in the team, we get through that in about 15 minutes. So the whole team will communicate with each other and talk about those three things. Then we'll decide what we need to adapt to for that day. And then we do that once a day, every morning together. And then in the beginning of the cycle, we take things from the backlog, we put them in, and we start working on them. And then we update in, I think right now, Jira is probably the best. So we use Jira mostly. Not everyone uses Jira, but my team does, to be able to take incremental progress and be able to keep everyone in the loop. So you get an email from Jira that says, hey, this person is working on this project. This is the latest work product they put into there. So we're all kept in communication, even though we're asynchronous, we're not working together at the same desk. We can all see what each other is doing, so we can help each other out. And then as we go through at the end of the 2 weeks, we look at, hey, what worked, what didn't work, what do we need to adapt to and change on our next sprint cycle. And then we do a variance report. So something that's really interesting in the culture here that is not part of Scrum, but something that I think is really valuable is we put together a variance to show these are the measures of effectiveness. This is how well we did last month. This is how, or last sprint. This is how well we did in this sprint. And this is what we project for the next sprint. So it uses data visualization so that our executives can look and our customers can look and see how well we're doing. and be able to monitor our progress. And it also gives us something to be able to talk about what we're doing instead of it being kind of nebulous. Oh, I'm 80% done. Instead you say, hey, this is what we were able to accomplish. These are the things we had to take out. These are the things we put in. And this is how we're doing as compared to last month. So we're just continually improving all the time. So there's this continuous improvement loop, which feels pretty satisfying from an engineer perspective. All engineers are puzzle solvers at heart. So having that measure really helps you see, is it working? Is it not working? And then to adapt if it's not working, or be able to put more emphasis on the parts that aren't working so that you get the best possible product.
So what do your code reviews and sprints deliverable sessions look like?
So I don't do code reviews. I'm sorry. I'm a systems person, so not as a software person. I don't do code reviews, so I'm not sure. But what was the other one?
Sprint deliverables.
Oh, sprint deliverables. So our sprint deliverables look like work products. We basically turn them into work products that get turned in. So for me, it would be like an interface control diagram. An interface control diagram looks like all the different pieces of the system working together. So you would see what protocol does it use, how long is the wire, what gauge is it, what's the power requirement, how does it fit, what are the actual connectors between the different pieces. Like that, for instance, would be a diagram or a set of diagrams. So the set of diagrams would show how everything fits together and what moves between one piece to another. So as an example, at the end, we would turn in that document and then we'd have it reviewed. So it'd be reviewed by an independent reviewer. So it's another engineer of my similar part of their career, and also by the customer. And then they would look at it, see if it needed any changes or modifications, and we put it back into the backlog if it needs any updates. If it doesn't need any updates, we turn it in, and it would be then go into the design and become a product that we would actually manufacture and put into our eventual systems, like a ship or a plane or something like that.
So now that we're getting close to the end, if anyone has some more questions, we'll wait a bit. But do you have any closing remarks?
Oh, just thank you so much for going out and taking the time to do hackathons. This type of exercise is so important to be able to learn how the tools actually work and be able to learn how not only you attack, but also how you defend. I can tell you it is these practical exercises that make the best people. And my best cyber engineers are the ones who go out and collect different cyber data, the ones who actually exercise their tools and try. So continue doing that and make sure you take credit for it. Put it in your resume. Don't forget to put this in your resume. And thank you for your time. I really appreciate you guys listening to me. I love this job and I love this company. So it's really nice to get an opportunity to show that to you. And hopefully you'll have the same kind of career and be able to do the fun, exciting things that I do every day. So thank you. And I guess I'll talk to you later.